Hello everyone, welcome to the Masons Online Classroom. Today, we'll be sharing about brick foundation construction. This lesson is divided into 5 parts, which are 1. Fundamentals. 2. Laying the brick foundation with wide footings. 3. Brick alignment and setting the base. 4. Construction process. 5. Creating a damp course. Through this session, we'll comprehend the essentials of building a brick foundation. Let's begin with the first part, which is the fundamentals. Brick foundations come in 2 forms: strip foundations and independent foundations. They consist of a foundation wall and wide footings. The foundation wall is the same thickness, or slightly thicker, as the wall itself. The expanded part at the bottom of the foundation wall is called the wide footing. Below the wide footing is the foundation bed. Depending on how the wide footing recedes, brick foundations are classified into equal height and spaced wide footing types. Equal height wide footings have a recess of 60 mm for every 2 layers of bricks on each side. Spaced wide footings follow a pattern where the first step recesses 2 layers by 60 mm on each side, and the second step recesses 1 layer by 60 mm on each side, alternating in this manner. Brick and stone foundations are constructed after excavating the soil, finishing the bedding layer, and establishing the lines and story poles. Before brick foundation construction, it's essential to be familiar with the construction drawings and to conduct an inspection of the previous step. The construction sequence is as follows: check the alignment, correct the elevation of the bedding layer, lay the base, set the wide footings, recess, build the main wall, inspect and apply the damp course to complete the base. Secondly, laying the brick foundation with wide footings and checking the alignment. Before laying the wide footings for the brick foundation, it's crucial to check the dimensions of the foundation groove, the thickness of the bedding layer, and the elevations. Additionally, ensure the correctness of the chalk lines and the placement of story poles. If the batter board has been removed, the center line should be marked on the slope of the foundation groove. Based on the axis line, mark the sides of the wide footing foundation and indicate the requirements for the wide footings and the position of the damp course on the story pole. When there are no specific design instructions, the wide footings and the foundation walls are generally built using an English bond. Because of the stair-stepping process, the construction is slightly more complex than the wall itself. The calculation for the width of the wide footing base is B equals B plus 2L. Here, the uppercase B represents the width of the wide footing, the lowercase b represents the width of the wall body, and L represents the width extending from the wall. In practice, considerations for mortar joint width are crucial. Once the width of the wide footing base is calculated, the next step is to proceed with the alignment and setting of the bricks. A 1-brick wall with 6-layer, 3-stepped equal height wide footings. This wide footing consists of 3 steps, each with a width of 1/4 brick length, which is 60 mm. According to the calculations mentioned above, the base width is B equals 600 mm, but considering the vertical joints, be 615 mm. A 1-brick wall with 6-layer 4-stepped wide footings, the theoretical width of the base is 720 mm, but it actually measures 740 mm. Its construction method is as depicted in the diagram. A 1-brick wall attached with a brick pier of a half-width layer and a popped-out layer. In this case, employing 4 layers with 2 recesses for the wide footings. The base construction method for the wall body is similar to the 2 examples mentioned above. The crucial aspect lies in the handling and recesses of the brick pier in relation to the wall body. As per the method, the width of the brick pier footing is 2 bricks, and the recessed width for the brick pier is 2.5 bricks. The construction method is illustrated in the diagram. A 1-brick independent square column with 6-layer, 3-stepped wide footings. Calculations determine the base width to be 2.5 bricks. The construction method is illustrated in the diagram. Thirdly, brick alignment and setting the base. Aligning the bricks according to the base dimension lines and the predetermined stacking method without mortar involves dry laying the bricks for a certain length, considering the width of the vertical joints. It requires thicker walls to be laid in header bonds, while thinner walls in stretcher bonds, termed as header in thicker walls and stretcher in thinner walls. The design is based on 100 units, while the bricks are at 125 units, resolving the discrepancy through brick alignment. The task includes aligning various sections such as corners, wall piers, openings, and junctions to meet both brick and design unit requirements, ensuring reasonable joints and convenient operation. Adjusting the width of the vertical joints resolves the discrepancy between design and brick units. Once brick alignment is complete, fixing the dry-laid bricks with mortar is called setting the base. Setting the base demands 2 things. First, it should not change the pre-established brick positions. 1 trowel of mortar per brick is essential for construction. Second, it must strictly adhere to the standard established by the story poles. Any significant deviations should be handled during the preparation phase. Fourthly, construction process, coping. Constructing wall corners at the turning points and major angles of the structure. The height of each coping should not exceed a height of 5 layers of bricks each time. Verticality is checked using a line and a plumb bob, ensuring conformity with the established story poles. Constructing steps. The foundation's wide footings involve the construction of steps. Each step must be measured accurately with a measuring tape, and the construction of the middle portion should align with the corner angle. After the steps are completed, a string line is utilized with a batter board to check the central line of the wall before constructing the foundation wall. Both sides of the seismic and settling joints are built according to the requirements of the marked line, and any excess mortar inside the joints should be handled promptly. The foundation's wide footings should have staggered joints. When using broken or fragmented bricks to fill in, they should be dispersed and placed in low-stress areas. Accurate reservations of empty cavities should be made, and no cavities should be created later. The mortar joints in the foundation must be tightly sealed to prevent groundwater seepage. The elevation and specifications of the overhead beams for pipeline trenches and reserved holes must be accurately positioned, and their seating should be solid and full. If the seating thickness exceeds 20 mm, fine stone concrete should be used as a cushion. The bottom of the ground ring beam and the sides of the structural columns should reserve pass-through bars for supporting formwork, which will be filled and compacted after dismantling the formwork. Finally, creating a damp course. Construction of the foundation damp course should commence only after the entire foundation wall reaches the designed elevation, preferably after indoor backfilling is completed. This process should be completed separately as a distinct procedure. It is not permissible to add waterproofing agents to the mortar used for wall construction in place of a damp course. The mortar mix for the damp course typically consists of a 1:2 ratio of cement and sand, with a 3% to 5% waterproofing agent based on the cement mass. If waterproofing powder is used, it should be mixed with water separately before being added to the mortar. If there's a concrete ring beam at the top of the foundation wall, it can replace the damp course. While applying the damp course, a horizontal reference line should be marked on the side of the foundation wall. A straight edge is then used to ensure a level surface. Spread the mortar evenly, allow it to be partially set, and then use a trowel to create a flat, rough surface. That concludes our lesson for today. Thank you all for watching.